Okay, well, we just finished last time our look at the solar system in general, and now we hone in on the center of the solar system, the sun itself. So let's sing our sun song, everybody. The sun is a mass of incandescent gas, a gigantic nuclear furnace, where hydrogen is fused into helium at a temperature of millions of degrees. You didn't learn that? Oh, okay. Well, we'll sing it later then. We're going to just look at some, first of all, so an overview of the sun itself, the facts about the sun, then 2 chapters that look at the implications of a secular origin for the sun and then a biblical origin for the sun. And then we'll wrap it up this morning with the sun provides life and the uniqueness of the sun. So let's look at our first video of this unit.
The sun puts out more energy in 1 second than 1 billion major cities would use in a year. We'll say, well, why would God make such a magnificently powerful object when we only need a small fraction of it? Well, he's God, why not?
If the Earth were to be orbiting an average star, it would be a red dwarf, and we wouldn't be here to be talking about it, probably.
Our star, I think, to be among the more stable types of stars, and he wanted it to provide steady amounts of energy for us, and so that's what it does.
We can see that we're just right where we need to be inside that habitable zone.
There's one shield after another, these ways that God has set up the earth for us. I think it all shows how this place was planned for us.
Every morning we wake up, there's a faithful companion that follows us through the day. Our lives would not exist without it. It's the sun, a hot glowing mass of incredible energy that impacts every part of our lives, whether we realize it or not. When you take a closer look into the sun, the facts are staggering.
The sun, of course, being the central star of our solar system and what's largely responsible for signs, seasons, days, and years, is basically a large nuclear bomb, an incredibly efficient power source. The sun puts out more energy in 1 second than 1 billion major cities would use in a year.
The sun is like 860,000 miles in diameter. It's about 109 times the Earth's diameter. Sometimes show people sunspots. You see an image of the sun sitting here, and I see these little dinky spots. And I say, well, those little tiny things? I said, yeah, but the sun is 109 times the diameter of the Earth, so those things are actually bigger than the Earth. Its mass is like 330,000 times the mass of the Earth, so it has 99% plus of the mass of the solar system inside of it, even though it only has about 1% of the angular momentum. The planets have all the angular momentum, which is kind of an odd thing when you think about it. It has a temperature of about 6,700 Kelvin, which in real temperature is around 11,000 degrees Fahrenheit.
And people say, well, why would God make such a magnificently powerful object when we only need a small fraction of it? Well, he's God, why not? It's not like it was harder for him to make that than it was to make anything else.
The internal temperature is on the order of millions of Kelvin. You can do a back-of-envelope calculation, just an estimate, and you get about 7 million for an average. I've done that estimate several times. Detailed models suggest the internal core temperature of the sun's around 15 or 16 million Kelvin, and that's high enough to sustain nuclear reactions, fusing hydrogen to helium. And we think that's the source of the sun's energy, and the sun can shine this way for 8 or 10 billion years, so not a real worry.
The core of the sun is where you have nuclear fusion taking place, and we have good evidence that that is taking place because it releases not only energy but also neutrinos. Neutrinos are these little ghostly particles that can go right through ordinary matter. They go straight from the core of the sun all the way to the Earth. There are several trillion of them going through you every second, amazingly. And they're hard to detect because they're so ghostly, but we do have neutrino detectors on Earth, and they've detected neutrinos coming from the core of the sun. So it's good evidence that nuclear fusion is taking place there. The next layer out is called the radiative zone because the radiation from the core streams out through that radiative zone. The next zone is the convective zone, or the convection zone, and that's where you have motion, all kinds of motion. The plasma bubbles up and carries energy from the inner sections of the sun out to the surface. And then, of course, you have the photosphere, the area that you actually see, and you get all kinds of interesting activity on that, sunspots and things like that. Sunspots are cooler regions where there's been a strong magnetic field that prevents motion. Magnets can prevent motion in plasma because plasma cannot move across a magnetic field line. And starved of their energy source, they just simply cool off. And so sunspots are a chilly 4,000 degrees compared to the rest of the sun, which is about 6,000 degrees. Above the photosphere, you have a very thin layer called the chromosphere, and it's normally transparent and difficult to see, but you can see it during a solar eclipse. That little ring during a total solar eclipse of very colorful prominences and things like that, that's the chromosphere. Chromo meaning color, because it often appears vividly colorful. Beyond that, you have the solar corona, which is a much larger layer of very thin hydrogen gas that streams out into space. And it's really can't be seen by eye, but we do have spacecraft that can detect the solar corona.
Okay, to question number 1. According to Genesis 1:14, why did God create the sun? To divide the day from the night. Yeah, along with the moon and the stars, they governed the light that was already there. The light emanates from God. We're told very clearly in Revelation, in heaven there will be no sun, because God is the source of all light. And in the presence of God, there doesn't need to be an object that's radiating heat and light. God will radiate whatever heat and light we need. But while we live here on this side of heaven, we have these objects, the moon and the stars, and especially the sun, that govern the light that God already called into being on the first day of creation. Sun, moon, and stars called into being on the fourth day of creation.
It's also there to do the signs and the seasons and the days.
Yeah, marking time, too. How do you know it's time to get up in the morning? The sun is up. How do you know it's time to go to bed? The sun is down. You count the numbers of sunrises and sunsets, and you eventually know how many days has passed in a given time. You count 365 of them, and you know that the earth has revolved around the sun one time, and so on. So the sun is an important marker for our time. Number 2, according to the video, how many cities could the energy of the sun power in 1 second? A billion. A billion cities. I'm not sure how they define cities. Probably gatherings of 50,000 people or more, but still, it's a staggering number. Number 3, what is the size of the sun's diameter? It's big. 109 times the Earth's diameter.
They say it's 864,000 miles.
Yeah, 864,000 miles to go all the way around the sun if you were able to go onto the surface. But it's 109 times the diameter of the Earth. Yeah, I don't think you'd last long enough to make it all the way around, no. And number 4, how much of the entire solar system's mass makes up the sun?
More than 99%.
Yeah, more than 99%. When we were just talking about the gas giants of Saturn and Jupiter the last few weeks and how massive they are compared to the sun, put all the planets together, they don't even make up 1% of the mass of the solar system because the sun is so huge. How much of the solar system's total angular momentum does the sun have?
1%.
Yeah, only 1%. It really isn't moving nearly as much as the planets themselves are moving. Now, the solar system itself, along with our galaxy, is moving too. But this angular momentum in relation to the bodies that are most directly near it, is minuscule in comparison with the momentum of the planets revolving around the sun, which just speaks to the power of the sun's gravity. Number 6, what is the internal temperature thought to be for the sun? $27 million degrees Fahrenheit. Well, when Charlie does a French roast, it almost gets that high, but not quite. And think of that compared to the surface of the sun. Even the surface of the sun, 9 to 11,000 degrees Fahrenheit. That's plenty hot in and of itself. 9 to 11,000. But inside, the forces that are generating all that energy, 27 million degrees Fahrenheit. And number 7, according to the video, how long is it believed that the sun could last? Another 8 to 10 billion years. So we don't really have to worry about the sun burning itself out or something. So.
And isn't that a good way to debunk evolution? Because if scientists say that our solar system is so old, the sun would have already burned out.
We're going to get to that, but yes. Yeah. But yes, you're right. So, all right. So we're going to look at the idea of a secular origin for the sun here in chapter 2.
So where did the sun come from, and how old is it if it came about by chance? We weren't there, of course, so how do we know? Does the secular story match up with the facts and physics, or does the evidence support a biblical worldview?
The sun is allegedly billions of years old, and it's probably a third-generation star, they would say, meaning that the first stars that existed, which would be called population 3, they're made of pure hydrogen, helium, trace amounts of lithium, because those are the only elements that can be created in the Big Bang. Not surprisingly, from a creationist perspective, we find no population 3 stars anywhere in the universe. Then the second generation of stars, which would be called population 2, would have small amounts of these impurities, which are called metals. In astronomy, anything heavier than helium is a metal, interestingly. And then the sun has a fairly large amount of metals for a star, approaching 1%, something like that, as opposed to just a fraction thereof. And so they think it's a third-generation star, which is called population 1. There are problems, of course, with the secular view of the age of the sun. One of them is called the faint young sun paradox. And this has to do with the nuclear physics that takes place in the core of the sun. Our understanding of nuclear physics suggests that as hydrogen is fused to helium, that reaction eventually becomes hotter because it changes the mean molecular density of the core, and that causes the sun to gradually heat up and brighten. And so, by secular thinking, the sun must have been about 30% fainter when it first formed, about the time life was supposedly first evolving on Earth. But if it was that much fainter, Earth should have been an iceberg. It was getting not nearly as much energy as we get today. And yet, if anything, the geological evidence suggests the Earth was warmer in the past. And so that problem is called the faint young sun paradox. It's not a problem, however, in a creationist worldview, because in 6,000 years, the core temperature of the sun hasn't changed very much.
There's an aspect of the sun that I think is very interesting that you don't often hear about. The sun, according to the secular solar nebula model, supposedly formed from this big cloud of gas and dust that then collapsed into a disk shape, and the sun formed in the middle and the planets. And as evidence for the secular model, a secular astronomer will point to the fact that all the planets line up pretty closely within a disk shape. There's no actual disk, of course, but their orbits line up in a disk, and they call it the plane of the ecliptic. There's an issue with this that's not commonly talked about. If that model were true, then we would expect the rotation of the sun to match the plane of the ecliptic. But it doesn't match. It almost matches, but not quite. The sun is actually tilted over on its axis by about 7 degrees. Now, 7 degrees doesn't sound like much, but you have to remember how big the solar system is. Neptune, the furthest planet, is about 2.8 billion miles away from the sun. If the secular model were true, we would expect the sun's equator to line up with the plane of the ecliptic. It doesn't. Because the sun is tilted, it's off. Extend that out to the edge of the solar system, and you see there's a 343 million mile difference between where Neptune should be and where Neptune actually is. And it's not just Neptune, it's all the planets. I'm using Neptune because it's the furthest one out. So you have to ask a question. If the secular model were true, why doesn't this match? Why doesn't the sun's equator match the plane of the ecliptic? Did something tilt the sun over after the planets formed? And if so, what could possibly do such a thing? Nothing we know of, other than something big enough to destroy it probably. Or did something move all the planets at the same time systematically? Which doesn't make sense either. There's something built into the very structure of the solar system that the secular model has a really hard time explaining.
Okay, so number one, what is the secular theory to explain where heavier elements came from, since the original stars couldn't have contained them? I don't know that we actually got a name for the theory, but the whole concept is that there are different populations of stars, and each, I don't know why they call them populations and not generations. Generations would seem to make more sense, but the first population were those original perfect, quote-unquote, stars that contained only hydrogen, helium, and lithium. Then there were the population 2 stars that contained trace elements of metal. We still see some of those today. And then later they developed, the population 3 stars developed out of nebulae that had all sorts of impurities in them, heavier metals and such. Not heavy metal in the sense that we talk about here on Earth with uranium and so on, but anything heavier than helium is a metal in an astronomical sense. But number 2, what fact was presented that goes against the idea that the Big Bang produced population 3 stars? Exactly. We haven't found any population 1 stars. They're not there, and the sun seems to be fairly unique in its stability compared to other stars too, which of course is exactly what we need to sustain life here on Earth, because if it were heating up and cooling down and expanding and retracting, well, life on Earth wouldn't be sustainable. Number 3, do they claim that our sun is a population 1, 2, or 3 star?
Population 1?
Population 3, actually. Because population 1 would only be helium, hydrogen, and lithium. Population 2 would have trace amounts of other gases, technically metals. And then population 3, our sun actually has some, almost 1% of metals other than helium, hydrogen, and lithium, which doesn't sound like much, but is not what we see in most other stars. Number 4, how old do secular scientists claim that the sun is?
4.6 million.
Yes, so basically equate it to when life on Earth appeared. So the sun is basically as old as life on Earth. So if you're talking about a universe that's 11 or 13 billion years old, for most of its existence, then the Earth didn't have a sun. Number 5, what is the faint sun paradox? If hydrogen and helium or hydrogen is continually being fused into helium in the core of the sun, science says that means over billions of years, the core should be heating up a lot more than it had. It should have a lot more heat than it had in the past. But if you then go back 4.7 billion years, the sun must have had roughly 30% less energy than it does now. And 30% less energy for the sun would equate to the Earth.
Being an iceberg.
just being a big iceberg floating around in space, totally unable to support life. And that kind of takes care of number 6 too. What disproves the idea that the sun was much cooler in the past? Yeah, if you're talking about a past that includes millions and billions of years, you're also talking about a sun that wouldn't have been able to provide the energy necessary to sustain life. And obviously, if you've got the millions and billions of years needed to explain the solar system and the universe without God, you also need those millions and billions of years to explain life on Earth without God. And the two don't match. Number 7, true or false, the faint sun is also a problem for those that believe the sun is only 6,000 years old. Why or why not? False, because in 6,000 years, has enough helium been fused?
Because it says the core temperature of the sun wouldn't change very much.
Exactly. It hasn't been enough time to change that core temperature of the sun in a measurable way. 6,000 years in astronomical terms just isn't that long, isn't long enough to cause long-term change. Number 8, what is the nebula model? The sun formed.
From a big cloud of gas and dust that collapsed into a disk shape.
Yes, and that's the key. It collapsed into a disk shape. And as this disk started moving around and the energy concentrated in the center, that concentrated energy became the sun. And then other bits of matter out in the far reaches of the nebula became the planets. But what evidence is provided for the nebula model?
Plane of the ecliptic?
Yeah, the fact that I always get rotation and revolving mixed up. The rotation of the planets around the sun all happens roughly in the same plane. And that's true, it does. There are a few little variations, but it's mostly in one plane. But what fact actually disproves the nebula model? The sun itself is tilted against the plane that the planets rotate on. So if the elliptical model would be correct, and everything came from this nebula into a disk, then the sun should have its equator lined up perfectly with the elliptic, but it doesn't. It's a 7-degree tilt, which works out to a 330 million mile problem when it gets to Neptune. And we don't know of anything in the universe that could have caused the sun to suddenly tilt on its axis like that. So, all right, before we take our break, we'll do number 3 as well, chapter 3, the biblical origin of the sun.
At the beginning of Genesis, the Bible describes the days of creation as real 24-hour days. The sun came along several days into creation, and there may be a good reason for that. Some try to interpret long ages in between the days of creation, which presents some big challenges to what we know about science.
According to the scriptures, the sun is made on day 4, which is kind of interesting because we had day and night before that. God provided the temporary light source. He made light on the first day, and He divided the light from the darkness on the first 3 days, and then He replaced that temporary light source, whatever it was, with the sun on the 4th day. People have asked, why did God do that? Well, the Bible doesn't specifically tell us, but one reason might be to displace the sun, making it 4th so that the Hebrews would be less inclined to worship it as the source of life. It's not the ultimate source of life. God is the ultimate source of life. And He is what creates on day 1. The sun is merely to serve in a particular role. It's a created thing. In fact, you notice it's not mentioned by name in Genesis. The sun is simply referred to as the greater light, and the moon the lesser light. And by not giving them proper names, it again makes them less inclined to be like a deity that would have a proper name. One really interesting thing is that plants, which make use of sunlight, were actually created before the sun. The Bible tells us that God made light first, and He divided the light from the darkness, and then the separation of the waters, and plants are on day 3. They're already using whatever that temporary light source was. So it's not a problem to have plants before the sun, and they were only there for one day before the sun anyway. That is a problem for those Christians who compromise and want to make the secular time scale line up with the biblical time scale. They would say, well, the days were long ages, millions of years each. It's a problem because you still have the plants before the sun. In the secular view, the sun comes before the plants. So you can't have that. And they say, well, maybe the light just appeared on the 4th day. I've heard a particular person that argues that view. But the Hebrew wording is very clear. God made the lights on those days. There's a different Hebrew word for appear. The word to make is asah, and that's what's used of the sun. It's made on the 4th day. It's not a problem if you take the Bible as written, if you let it mean what it says. It's a huge problem, though, if you try to compromise with any other position.
Okay, under biblical origin questions, number 1, did the first light come from the sun? No. God said, let there be light. He was the source of the light. Now, Dr. Liesel there made the supposition that there was a temporary light source. I don't know that we have any evidence for that necessarily, just that God Himself produced light. He called it into being, and then He called it to rest for the night so that there would be night and so that there would be day. God did all of that. Number 2, how long after the creation of the sun were plants made? Trick question. The plants came before the sun, day 3. Number 3, according to Dr. Liesel in the video, what is one reason that God might have waited until the 4th day of creation to make the sun?
Well,
Yes.
He did want the Hebrews to be more inclined to think the sun is where life came and worship.
Yeah, think of all these other ancient cultures, especially the Egyptians, also the Babylonians, Assyrians, who had some form of sun worship. Kind of makes sense if you in your mind are creating your own system of deities and making God up in your own mind. Well, you understand, even as an ancient person, that a lot of power comes from the sun. And the sun is pretty important. God minimizes the importance of the sun by letting Earth go for 3 days before He puts the sun up in the sky. Perhaps that is what God had in mind when He waited until day 4 to create the sun, moon, and stars. Number 4, what problem does the creation account of plants and the sun create for those that believe the days of creation are actually millions of years old?
Because the sun was created long before the plants, but it appeared on the 4th day.
That's their reasoning. That the sun was there, you just couldn't see it really. It appeared. You couldn't see the sun for millions of years. In and of itself, that doesn't strike me as being very...
It says there's a different word for appear in Hebrew.
Right.
It's baha.
But before all that, just the fact that you've got the earth existing, according to the people who want to synthesize Genesis 1 through 11 with the evolutionary model, you've got the earth existing for millions of years without a sun and plants growing without a sun. That doesn't seem to make a lot of sense. So number 5, how do Christians who believe in the millions of years try to get around the problem mentioned in question 4? And that's where you get to what Debbie was talking about. Like, well, the sun just appeared. It was always there, but then people were able to see it. I don't quite grasp that argument, but it doesn't work. It doesn't work logically, but it doesn't work grammatically from Scripture either. It clearly says God made it, and that's number 6. What is the problem with claiming that the sun just appeared instead of being made on the 4th day of creation?
Because the Hebrew is asa, which means to make.
Yeah, the word is make, not appear. There is a Hebrew word for appear, and that's not there. So we'll take our break now and come back in about 10 minutes and do the sun provides life and the uniqueness of the sun. All right, welcome back. We're going to pick it up with chapter 4, The Sun Provides Life.
We know by studying creation that the sun is essential for life on the earth. It's as though our Creator designed the perfect placement of the earth and the energy of the sun to work together. In fact, it's called the Goldilocks zone, and it challenges the laws of probability if our solar system came about by chance.
Okay, sun produces energy that's radiated here. It takes about 8 minutes to get here. It's a wide part of the spectrum. The bulk of it's coming in infrared, which is blocked out, but we have visible that comes through. And radiation makes it through does several things. Number one, it heats the earth. We get warmer temperatures in the day and cooler at night. And there's a nice regulation going on there that gets into planetary and atmospheric sciences.
And of course, plants make use of the light, and they're able to take that and use that energy to convert to create things like sugars. And then animals and human beings are able to eat those sugars.
Animals eat the plants, or they eat the animals that eat the plants, or they eat the animals that eat the animals that eat the plants. We all go back to plants, which all goes back to solar. And so this is this free energy coming in, more or less. And only a tiny fraction of the sun's energy is actually hitting the earth, and only a tiny fraction is actually harnessed. If you're too close to the sun, it's too hot, you don't have liquid water, and without liquid water, life is impossible. If you're too far away, you don't have liquid water, it's all frozen, life is impossible. So you can define a very narrow zone, the habitable zone or the Goldilocks zone, and the Earth is there, and we don't have to move the Earth around to ask what would happen. We've got two planets, one on either side. Venus, too close, it's very hot. It's got the hottest surface of any planet, hotter than Mercury, which is even closer to the sun, because of the greenhouse effect that it has. And then farther out you have Mars, which is a very thin, inhospitable place, very cold there. The warmest day on Mars is still worse than the coldest day on Earth, so it's a pretty rough place. And so we can see that we're just right where we need to be, inside that habitable zone.
Okay, probably not a lot there that you hadn't already thought of at some point during your life. What type of energy does the sun emit?
X-rays?
Yeah, there's no one type. You've got, yeah. You have the X-rays, ultraviolet, infrared, visible, electromagnetic, and gamma. Yes. Number 2, what color of visible light comes from the sun? All kinds, but when you mix them all together, you get white light. Yeah, so we see everything in neutral white light. Just think, if we had just different shades of light coming from our sun, we'd be seeing everything with an orange hue or a red hue or a blue hue. Instead, we have nice neutral white light that we can see everything in. Number 3, do all the types of radiation from the sun make it to the surface of the earth? No, and if they did, we'd be in bad shape, because some of those types of radiation, gamma radiation and such, that they would cause big problems for us. But our atmosphere filters out the dangerous radiation from the sun and allows in that which we need in order for life. Number 4, how's the sun responsible for the food chain here on Earth?
It warms the earth, which warms the plants, which send off the energy and the sugars.
Yeah, everything in the food chain eventually boils down to plants. You either eat plants, or you eat the things that eat the plants. Or you eat the things that ate the things that ate the plants. Eventually, it all gets back to plants. And just as we were talking about with the necessity of the sun growing everything here on Earth, and how the thought that if the days of creation are only allegorical and stand for millions and billions of years on their own, you had a sun that came up after the earth had been producing vegetation for billions of years is ludicrous. The plants were created on day 3, but they're only around without the sun for 1 day, and they used the light that God had already put in place there. We need the energy of the sun to create photosynthesis and create all of those nutrients and sugars that then become food. Number 5, again, we talked about this a couple of weeks ago. What is the Goldilocks zone? Just right. Not too hot, not too cold, just right. And that's where we are in the Earth, and we can see that by comparing the Earth to our 2 neighboring planets, Venus and Mars. Venus, far too hot, 1,000-degree surface of Venus. Too hot to sustain life. Mars, the warmest day on Mars is colder than the coldest day on Earth. Yes.
I didn't catch it, but why is Venus warmer than Mercury?
Venus is warmer than Mercury, even though Venus is farther away from the sun, because Venus has an atmosphere. And that atmosphere creates a greenhouse effect and traps the radiation from the sun and is continually warming the planet. Number 6, why is it important to be in the habitable zone for liquid water?
Because if we weren't, it would be, let's see, demonstrate, which is close to the sun, hot surface, even hot, no, I lost my.
Now, let's just go to the planets that are near us again. What if you poured out a cup of water on Venus? Instant boil, steam, 1,000 degrees. What if you poured out a cup of water on Mars? Ice. For there to be liquid water, which we need, because we need liquid water for plants to absorb, for fish to swim in, and for us to consume. You have to be in this perfect zone. Number 7, what planet was used to demonstrate what happens if we were too close to the sun? Venus, not Mercury, because Venus is hotter, even though it's farther away. And number 8, why is the warmest day on Mars colder than the coldest day on Earth? It's partly because of the atmospheric differences, but mostly because of the distance from the sun. The planet Mars lies outside the Goldilocks zone. All right, and then we're going to finish today with looking at chapter 5.
The Bible tells us that on day 4, God made our sun just for us who live on the earth. Astronomers have searched the universe for more stars and estimate there are 10,000 billion of them. With these numbers in mind, some say our sun is pretty mundane, discounting God's special design. But it's not mundane at all when you take a closer look.
You often hear comments about how our sun is ordinary or average, or as Carl Sagan once said, humdrum. That's not at all true. Our sun is unique.
There are stars that are much bigger than the sun, much bigger, some of them hundreds of suns across in diameter. But there are a greater number of stars that are smaller than the sun. But the sun is kind of in the middle of those two. And it turns out that red dwarf stars, which may be half the size of the sun, they're just everywhere in the universe. Chances are, if you're a star, you're a red dwarf. That's just the way it is.
Now, red dwarfs, as you can gather by the name, they're red and they're very small. They emit about 5% of the energy of our sun. So in order to get enough energy to be warm enough for there to be life here, the Earth would have to orbit the star very closely. So closely, in fact, that there would be a tidal lock, where the same side of the planet would always face the star. That means that you have one side that's always hot and the other side that's always cold and dark. So you can't have anything growing on the dark side, obviously. And there's another real question about whether anything could grow on the lit side of such a planet too, because the star emits reddish light, not greenish light, which is primarily what powers photosynthesis. So whether or not plant life could even exist on this planet is a real question. Of course, without plant life, we couldn't live because it's the foundation of the food chain. And even if all that weren't a problem, orbiting a red dwarf closely will get you into trouble eventually, because red dwarfs are very unstable and they flare frequently. They're sometimes called flare stars. They erupt and they blast superheated surface material out into space.
A flare is actually sort of a hot spot, a bright spot on the sun where magnetic field lines have snapped and they've released an enormous amount of energy.
So any planet that orbits these things close up gets sterilized. So if the Earth were to be orbiting an average star, it would be a red dwarf, and we wouldn't be here to be talking about it, probably.
Some astronomers have been looking for solar analogs, that is, stars similar to the sun. We can look at the temperature of the sun, the size of the sun, so what we call a main sequence G2 type star. And what they found very interesting about the sun is the fact that the solar analogs we find are very active. They have apparently a lot of sunspots, a lot of chromospheric activity, more so than the sun does. And these things vary in brightness, appreciably so. The sun doesn't appear. If it is, it's like, 0.001% or something. Well, some of these stars are varying by several percent. As you find more and more of these being very active, it's obvious that they're not the weirdos. The sun is the weirdo.
And even among class G stars, stars very much like our sun's unusual, most of those are in binary or multiple star systems. A binary pair is where two stars are orbiting their common center of mass. In a multiple star system, you can have 3, 4, 5, 6 stars orbiting their common center of mass. As you can probably guess, a system of stars like that makes things very complicated for any planet orbiting such a system. Sometimes it's going to be receiving a lot of energy and sometimes a lot less, depending on its relation to all these various stars. And its orbit may not even be circular, it might be more elliptical, in which case it's going to receive a lot of energy and then a little, a lot of energy and then a little. But we don't have that. We have a single class G star.
The sun is remarkably stable for a star, just remarkably stable, and that again is a feature that's designed for life.
Okay, and then some questions to help us highlight the uniqueness of the sun. According to the speaker, who said the sun is humdrum?
Carl Sagan.
Carl Sagan. Just a boring star. It's not when you look at it because it's got unique qualities to it. Number two, if the sun is going to be another type of star, according to the odds, what type would it most likely be and why? If the sun is a random star, what if you're looking at a star, what is that star probably, according to its classification? A red dwarf. They are the vast majority of stars out there. Red dwarfs. And would a red dwarf be able to support life on Earth?
No.
Probably not. We'll talk about that in number three. If our sun was a red dwarf, what would the Earth have to do in order to get enough energy for life, and what would be the result of that?
It would have to be really, really close to it where only half the Earth would ever get light.
Not only would the proximity of our rotation around the Earth have to be really, or the sun have to be really close, but we'd have to. Question number 4 already talks about tidal lock, and we'd have to be locked in place with just one side of the Earth facing the sun at all times, meaning one half of the Earth is completely dark all the time and unable to sustain light. Not only that, we'll talk about that with number 5, but the red dwarf gives off 5% of the energy of our sun. And so it's if you don't believe in God, you have to say, wow, what a lucky coincidence that we just happen to be by this perfect star that we need to sustain life. But God created it to sustain life. Number 4, tidal lock, we just talked about. And to always have a dark side of our planet, just imagine that one side never gets any light and no heat either. Very cold, very dark, probably uninhabitable and unusable. Number 5, if a dwarf star was our sun, would it be likely or unlikely that the light from it would enable Earth to support life?
No, because in order to get enough energy, the Earth would have to very closely orbit the red dwarf.
It's not, and the light itself, remember what we talked about in terms of the different light that comes to our Earth and then combines for nice bright white light? Well, a component of the bright white light is the green light that plants need for photosynthesis. What does a red dwarf put out? Red light. To be just in that reddish light, it's unlikely that that red light could support plant life. I guess it hasn't been tried, but from what we know of the plants that we have, they need light other than the red light.
And it also says that the red dwarfs are very unstable.
That too, yeah, the red dwarfs are unstable, putting out flares. And they talked about these flares as sort of sterilizing the planets that are near them, because the flares are so filled with energy and radiation, they just sort of soak over the planets that they hit and erase whatever would happen to be there. Number 6, what's a solar analog? It's the opposite of a solar digital, of course. No. Solar analog.
Star similar to the sun.
Analogous means like something. A solar analog is a star that's somewhat like our sun. It's like it in size, like it in energy. But there should have been a follow-up question here. What do we find with all these solar analogs? Although they are the same in some ways, what differences do all of these solar analogs seem to have? They are very active in the sense of shooting out flares. And we noted in the previous chapter how amazingly stable our sun is. We need it to be stable because we need to be able to count on the energy that we're going to get on Earth from day to day. How is it that weather forecasters can actually make an educated guess about what the weather is going to be? Forget about tomorrow, but a few months from now. Because they're counting on the sun being stable. And they can do that because God has put the sun up there to be stable. If it weren't, you would never be able to guess from day to day what the climate would be. Because you may be in the 150s if there's a flare that's coming out and aiming itself towards Earth. Or if there was a big set of sunspots that was blocking the sun's activity from coming in this direction, maybe we'd be negative 50 out of nowhere in the middle of summer. You wouldn't be able to count on anything if the sun weren't stable, and the sun is stable.
It says the activity of the other ones would cause variation in brightness.
That too, yeah. And the solar analogs, on average, they say, are 1,000 times more active, more unpredictable than the sun. So this thought, well, you know what, there probably is some solar system out there that's got life forms like we have out there, because this accidental life that came here probably happened somewhere else. No, God created everything just the way it needed to be in order for us to have life here on Earth. So, all right, we're going to pick it up, and I think we'll be able to finish off the sun next time, but we'll see. And if not, we'll look to move from the sun. I believe we go from the sun to the moon then in the next unit. So let's close with a short prayer. Lord God, Heavenly Father, we are so dependent on the sun that you put up in the sky to govern the light and to mark days and seasons, and at the same time, it's so easy to take it for granted. But what a wonderful picture of you we see in the sun, that you are constant. You are always there to provide for us, and that we can count on you as certainly as the sun rises and sets each day. So your presence is always with us, and your bountiful hand provides all that we need. Help us to appreciate you and your goodness through our continued look at the solar system and the individual bodies that you've placed in the sky. In Jesus' name, amen.